5 similar videos ready to start this channel with, all aimed at an AI career. Each one uses Vagrant as an infrastructure as code tool to build environments with the same stepping stones. It's pets v cattle. Whereas, if you look after your pet, if you do things manually, whereas if it's just all automated, it's just like cattle. You can have 10, 20, 30, 40 machines, all the same configuration, all good. And we want no outlay. So if you have any spare capacity on your laptop or desktop, we'll run this stuff in a VM or a virtual machine, or we can use Ubuntu or a Raspberry Pi or an old PC. Unfortunately, this is the third video, and this one actually requires an Intel chipset to make it 100% work. We could probably change that in future because Google do provide the software. So if anyone's really interested in getting this stuff running on a Raspberry Pi, we'll do it. It's more to teach it about Docker components, the specific one. So the 5 videos, the 2 I've already recorded, there's one where we build Peppermint, which I call login system, one where we build WordPress, which is a blog. This one is on Google's Kubernetes demo, and it's brilliant. It's a microservices demo that's brilliant. It teaches you about Kubernetes. We are going to take the file, hack it about so that we can run it on the simpler Docker Compose. And the next couple of videos will be on DeepSeek, which is an LLM, and NAN, which is an AI automation tool. And we'll tie these videos together with a blog or a book if there's interest for that. So here's the GitHub address for the Google Cloud microservice demo. It is actually brilliant. So what it does is and this one's about teaching you Docker images and how they all interact together on Kubernetes. We're going to get them to interact on Docker Compose. So as you can see, there's lots of videos on YouTube about this as well. So they're very good if you want to learn to be a microservices programmer. Whereas for AI, we really want to know that the microservices, what they are, and they work together. We don't need to know too much detail about them. So in this case, we're going to actually build it on an AMD NUC because it's Intel. I'm actually running on an Apple M1 MacBook Air, which is Apple Silicon. So we'll show you the config and how about half the containers run, because the containers have been compiled to Intel or x86, whereas they all run in the AMD NUC. So an PC or an Apple Mac will do fine. And if you don't have anything, what we can see is on AWS you could have an EC2 instance, which is Intel. On Azure you could have a virtual machine, and on Google Cloud you could have a compute engine if you really wanted to. Be careful, I've run up thousands of dollars by accident with a misconfiguration. So we're only going to go to the cloud if we really need to. We're going to try and use the capacity in your laptops or a Raspberry Pi for every demo. So the commands, it's the same commands basically that I've used in the Peppermint WordPress demo to build the environment. As you can see, we disable the firewall, we stop the app armor, we stop swap, we install Docker, the Docker components, and Docker Compose. And on the file, we're going to have a Redis data folder where we store the Redis data. Okay, the containers themselves, there's a lot more. So this is learning about them. So we've got a Redis container, which is an off-the-shelf Redis container. And what we've got is the rest have been written in various languages. So it lets you know that developers can write their own code and package it, and the container will run anywhere. So what we've got is we've got several Python programs, 4 Go programs, a Java, and a C# and some Node.js programs, and they're all running together. The box in the pink is the network port they're going to be all listening on. So the front end is on 8080. So that's the one we're going to connect to. and I've allocated these ports. So in the Kubernetes demo, they may use the same ports, but for Docker Compose, we have to split them on a unique port so that we can run them all at the same time. And what happens is the front end calls various calls. So this is what a microservice is. A microservice is basically one container calling another container. So we've mapped out which container calls which. More than one container, so like the cart service is called by the checkout service and the front end. And that's how it works. And the Redis cart at the back writes the data, but everything else runs in memory. Okay, let's have a wee look. So if I do Docker Compose up, we can see that all the containers have been loaded, or sorry, they've been downloaded and started. So if we do Docker stats, let's see. It's hard to tell on this screen because I've zoomed it up, but they're not all run. So we'll Control C that. And what we'll do is this is the NUC. This is what the build, and you can see we go to sunglasses. So if you want to buy sunglasses, you can add it to cart. Very, very pretty. Continue shopping, do the payment, place order. Not now. And it's worth playing about with and seeing the different logs to see how we can complete. Out of interest, I'm actually going to just check to see if 253, which is the box we're running on, is working or not. I don't think it is. Yeah, it's not working because of the Intel images. So the other thing to look at is we do an ls. We'll have a wee look at the Docker Compose file. Go to the top. So as again, what we've got is we've got the services. Each service describes a Docker component. I'll attach this file, but basically the email service is going to a sample microservices email service image, it's grabbing that, and it's running on port 5000. The checkout service, it's getting under a different program, it's running on 5050, and it needs some environment variable. So this is how the checkout service knows where the other stuff it calls are hidden behind it. Recommendation service, again, it's got details of what it calls. Nothing too complicated, but it's just to give you an example that we can run lots and lots of different things. And I hope you found this enjoyable. Probably more enjoyable when you get the files and are able to look at the Docker logs to see what's going on between each call. I'll get it. I'll go back to 25. HTTP call /192.168.1.25. This is my NUC. It's on 25, and there we go. We've got the website. We can do currency conversions, I think, or maybe we can't. Watch add to cart. So it's worth an experiment, and it's just to show you that lots of Docker components can run together. So thank you very much.